Delta D is equal to xf minus xi. That's displacement. Oh yes, I want to talk a little bit more about this here. Okay, these two V's here, we need to talk about this. I know I mentioned it before, but I'm going to emphasize it again. Delta V stands for change in velocity. How much it changes. V bar stands for the average. Those are not the same. If you insist on just writing V equals D over T, you're going to get messed up. Okay? There will be at least 3 or 4 of you that I will write on your test. I'll write delta V is not equal to V bar on your test because you're mixing them up. Don't be that person. I challenge this class to be the one class that I don't have to write it on the test. Delta V and V bar are not the same. And which one goes in the acceleration formula? Delta V, because acceleration is the change in velocity over the change in time. It's how fast the velocity changes. You get a half page sitting inside.
What's that other?
Yeah, I'll get to that one. Yeah, right away. Okay. V bar stands for the average. Think about average of tests. Different than how much better you did. Different. Now, I'm going to add this one in here in blue as well, although technically you know it already. The average velocity, when you have two velocities, how do you find average? Average of two tests? You add them together and divide by 2, exactly, right? So it says V bar equals VI plus VF over 2. You add the initial velocity and the final velocity and divide it by 2. Do you have to be careful on some calculators that you actually do that? Yes, you do. Okay, because if you just go like 6 plus 8 divided by 2, which one is it going to divide by 2? Just the 8. So be careful. Look at it. Think about it. The average means in the middle. Yeah. Yeah. Okay, the one way around it is to go VI plus VF equals 6 plus 8 equals, divide by 2, you should get 7, right? Think about the number. Is it in between the two? If it's not, fix it. Think about it. Okay, I'm going to give you lots of practice here.
What's that? X? Is that X?
XF minus XI, right? Delta D, change in position is final position minus initial position. Delta V, VF minus VI. See, I know I don't have the best handwriting. A equals delta V over delta T. V bar equals VI plus VF over 2. And V bar is equal to D over T. Alrighty, let's begin. I'll start you off with an incredibly easy one. What's one of those ones that's so easy we make it hard by complicating it? An object starts at a position of minus 6 and ends up at a position of plus 10. Calculate its displacement during the trip. Oh, one more thing. Oh, did I close that? Yeah. On our criteria the other day, we didn't talk about writing down the givens. With my grade 9s and my grade 10s, I insist. Some fight me on it. I sometimes don't win those battles. What I've found over the years is the people that write stuff like this starts at a position of minus 6, xi is equal to minus 6, and a final position of plus 10. Okay, you can write those down. I'm not going to insist. I'm going to suggest. What I find is the people that do actually listen to me are the ones that don't actually need to do it. It's the ones that don't write them down that struggle. And then they still refuse to write them down because it's a big waste of time, but yet they still get zeros. And they wonder why. And if they would just listen, they might do better. So if you feel that you should do that, you should. And if you feel that you don't, well, that's okay. But I might suggest it to you later if you're still having trouble. Okay? At the very least, you could circle the numbers or something other. Identify what you know. It's not going to come right out and say the initial position. You have to do some reading. An object starts at a position. That's the initial. Ends up. That's the final. Calculate its displacement. So delta D is final minus initial, right? Line up your equal signs, XF, 10 minus. Now I particularly chose minus 6 because this is the classic mistake, isn't it?
Yes.
What did I do wrong, Cole?
You put negative.
I forgot the negative, right? Because this is really the subtract. It's subtract negative 6. Excuse me. It may help to put it in brackets like that for you. Now I added an extra step in there. 16 what? Meters, yeah. Have I made that overly complicated?
No.
Well, you go ahead and say, yeah, I'm not going to be offended by that, right? I mean, it's really just 10 minus 6. I can do it in my head. It's plus 16. Write down 16 and go on to the next question. It's at the bottom, right? Okay. If all I care about is the answer, then that's true. But I do care a little bit about how you got it. Okay, and we got to build that putting your steps down kind of. You saw the questions that I gave you the other day there, the grade 12 ones. They were 4 and 5 mark questions, and those guys get bigger ones. So writing your steps down is really important. Okay, this one I've got 2 parts. When there's a 2-parter like this, label them A and B. Keep them separate so I can see. Many of you have pencils. I'm happy about that. Many of your pencils have the important part on the end, the eraser part.
Okay.
Don't be a rebel. Be a fudgicle and use your eraser. I remember as a kid never remembering the difference between a rebel and a fudgicle. Could never figure it out. I don't know why. You know the difference?
Rebel has ice cream in the middle.
Yeah. Fudgicles are just like the same thing throughout, right? Yeah. I remember thinking, I could never get it straight. Object moves from a position of plus 10 to a position of minus 13 in 7 seconds. Find its displacement and then its average velocity. Okay, so that is initial position. That's its final position. That's the time. If you just want to do that, that's fine too. Identify the givens. What do you know? We're looking for displacement. Line up the equal signs. Minus 13, subtract plus 10. Minus 23. Okay, so the displacement is minus 23. The average velocity. V bar equals d over t. Minus 23, the time, 7 seconds. You're going to need a calculator. It's physics. .3. Have I? Negative. Thank you. Have I done my rant about sig figs?
What? No.
No?
Decimal place?
I haven't done my what do we round them off to, sig fig rant?
No.
I don't think I have with you guys.
Yeah, you heard it.
I usually say one more decimal point than what is given in the question. Okay, let's look at number 3. You think you can do this one on your own?
No.
Find the time required to travel 150 kilometers at a rate of 80 kilometers an hour. What do we know? Distance and 80 kilometers per hour. Velocity. V equals 80, distance is 150. Find the time. I'm solving for t. What formula has t and d and v in it? V bar equals d over t. Is that 80 kilometers an hour constant? You have to assume it is. It doesn't say anything about it starting from rest or speeding up or slowing down. You have to assume that's constant. So it's V bar is equal to d over t. Right? This is probably something that you did in grade 10. I prefer putting the numbers in and then doing the rearranging. If you are someone that wants to rearrange it first, by all means. I just find that grade 11 students aren't usually quite ready to do that, the majority of you. So I prefer putting the numbers in. So I got an 80 there, I got 150 there, and I got a T on the bottom. Now I picked this particular question because it's the hardest one to solve for grade 11s. Cross, multiply, divide, says Graham. Do you know why, Graham? Well, that's true, right? You got to isolate the T, right? You want to have T equals. How do you get rid of divide by T? You know that whole solving equations do the opposite thing? Multiply by both sides by T. Those guys cancel. Now I got 80T equals 150 kind of thing. And then I got to get the T by itself, so I got to get rid of the times by 80. Divide by 80, right? I like to say the 80 and the T just switch spots when you're in a situation like that. 150 over 80. Okay?
You just rearrange the equation for you.
Some people prefer to do that. If you want to go to this, if you want to write T is equal to D over V, whoops, and you can do that accurately all the time, be my guest. That's just not the way that I suggest. But I'm certainly able to do it. And I can follow what you're doing. And again, showing your work, showing me your steps, goes a long way to me reading your mind.
1.8 something.
1.8 something. 1.875. What should we round that to? I'm going to round that to 1.9. Oh, hang on. 1.9 what?
Hours.
Hours. 1.9 hours. Let's find the time required, right? How many minutes is that? Good question, Greg. How would we do that? Yeah, multiply by 60. Now here's where I would just take, I wouldn't clear my calculator. I would take that 1.875 and I would just multiply by 60. How are you feeling about these? Okay?
Good.
Okay, well I'm going to burst that bubble. How much room you got for this one? A lot. How would you feel about splitting that space, trying it on the left-hand side? I'll give you a few minutes and then I'll do it on the right-hand side. You want to try it? You try it while I'm doing the attempts. If you can't, that's fine. I will show you the answer. I was on pause. I don't know why. Delta V is equal to 14. Here's a question for you. Is the average, is the final velocity always equal to the change in velocity? Is the final velocity always equal to change in velocity? Peter's shaking his head and saying no. Exactly. That is only true when you start at 0. Now, I would wager against probably 75 to 80 to 85% of questions, the initial velocity is 0, because that's just how things work. So people get lulled into this false sense that the delta V and the VF are always the same, but that's not true. It's only true if the initial is 0. Does that make sense? Only true if the initial is 0, so don't make that assumption. Now, do I need to see this step here?
No.
I'm a little bit torn. Some of you, I think, should do it. I think I would probably get better results if I insisted. I would also get battles that I don't want to fight with people. I think that you guys can look at this question, oh yeah, well the initial is 0, the final is 14, the delta V is 14. I can do that in my head. Okay? The danger is when people put 7 in there. Don't do that. So it's 14 over 4, 14 over 4, 7, 3.5, right? Right here. 3.5 meters per second squared. How much do you think a question like that would be worth? 100 marks. Come on. A mole of marks.
5.
Probably 3. Yeah. 1, 2, 3. Do I need to give you a mark for this?
You should. 5.
Half a mark at least.
Oh, I mean everything in total has to be 9.
9.
Well, there's 3 free.
I said 5. I'd say
We
6.
showed our steps.
Or
We showed
6,
the
yeah.
proper formulas.
Where'd you get
I'd say 6.
Wow.
I
Okay.
got 3 different.
Well, the likely were 3. I'm still debating on my marking scheme, but currently that would be.
One for the work, one for the answer.
Now, here's a great question, Graham. What if, for some crazy reason, you write 28 over 4 and you write, I don't know, you write 4 there. You do everything else right, but you put a 4 there, you make a 4 here, you do everything right, you get 8, everything's right. What would I give you?
2.5.
I'd give you 2.5, yeah. In fact, if everything is super neat, if you wrote down everything and all I saw was I might even on a good day, I might even give you 3 out of 3. Because you've shown me you know what to do, you just don't know how to use your calculator very well. And you've shown me in the other 2 steps, well, yeah, I can use my calculator, I just have fat fingers or whatever, I don't know, right? Who knows? There's a possibility I can give you 3 out of 3. Ready to try the last one? Oh, we're run out of time here. Ready to try this one?
Yes.
Now, let me just give you a couple hints here. Initial velocity of 1. Red flag, warning, initial velocity, not 0. Final velocity of 12. Are there any other numbers given in the question?
3 seconds.
Yes, occasionally they like to hide stuff in words. I don't know why. Find the acceleration. This sounds an awful lot like this question, just not just that last part, right? Okay, go ahead. Okay, I'm going to show you something that I'm going to try out with you guys as well. Sort of a thinking backwards. Because what I find is kids write down a formula and they realize, oh, I can't use that one just yet. Oh, I'm going to need, and they end up writing down the formulas in the wrong order.
Yeah.
Okay, I find that happens. So I'm going to try this on you guys, okay? If I want to know the acceleration, I'm going to write sort of like a little map kind of thing. Find the acceleration of the body during that time. So I'm going to use A equals delta V over delta T. That's my final one. Do I have delta T?
Yes.
3 seconds. Do I have my change in velocity? I don't. So I'm going to need delta V next, right? To get this one to work, I'm going to need this. Okay, so, and I think I have VF and VI, don't I, right? Okay, so this is the backwards order, so what do I write first? Now I have this ability. You don't. Right? But eventually you should be able to sort of do it in your head. So there's my steps, right? Delta V is equal to VF minus VI. So that's going to be 12 minus 1. And I picked this as an example. I want to show you that this is not always the final velocity here. So A is simply going to be 11 over 3, 3.67, I think, right? Or 3.7 meters per second squared. Okay, I've taken up a lot of your time today. I've been very happy. You've been very patient with me. It's time for you to try some. I gave every table 2. There's a whack there of questions. There's a QR code, I know. And I also put the solutions up on the wall there for you, over there beside Justin, if you want to go have a look. Okay, so I'm going to give you the rest of this time. We'll check in tomorrow. I will record these quizzes and get them back to you.